Good morning and welcome to Mr. Boskin Does Some Math. Today we are doing Illustrative Math Grade 8 Unit 7 Lesson 12's practice problems. Okay, our first problem is which is larger, the number of meters across the Milky Way or the number of cells in all humans? Explain or show your reasoning. Move this down so you can read it all to begin with. So, we want to know what is bigger, the number of meters across the Milky Way galaxy or the number of cells in all humans. So, we know the Milky Way is about 100,000 light years across. We know 1 light year is about 10 to the power of 16 meters. So we need to figure out how many meters it is across the Milky Way. So for that, we just have to take the number of light years across the Milky Way times the number of meters in a light year. So to multiply those, we have 100,000. First, let's put that into scientific notation. 1 digit in front of the decimal point is 1 times 10 to the power of, how many spots are we moving that decimal point? 1, 2, 3, 4, 5. 1 times 10 to the 5, and then we're multiplying it by 10 to the 16. Remember, when we multiply with like bases, we add the exponents. So we wind up with 1 times 10 to the power of 16 plus 5, which is 21. Now we need to, I should label this with units. It's the number of meters across the galaxy. So now we need to figure out how many cells are in all humans. There are 37 trillion cells in a human body. 37 trillion is 37. I should move this so it will fit on your screen. 37 trillion. 37. So thousands, millions. 37 trillion. These are thousands, millions, billions, trillions. 37 trillion. So 37 trillion we would write with scientific notation as 37 times 10 to the power of, how many spots did we move that decimal point? 3, 6, 9, 12. And one more to put the decimal point there. We want 3.7 for correct scientific notation. 3, 6, 9, 12, 13. So that's how many cells are in one human. The world population is about 7 billion. What does 7 billion look like as a number? Well, thousands, millions, billions, 7 billion. So we're going to be multiplying that times 7 times 10 to the power of how many spots did we move the decimal point? 3, 6, 9. So, thanks to the commutative property of multiplication, these are all being multiplied. We can rearrange this a little bit to make things easier for us. So we can now have 3.7 times 7. Those are just numbers we're multiplying, and then multiply our tens, 10 to the power of 13 times 10 to the power of 9. So that will be 3.7 times 7, I'm just leaving that for now, times 10 to the power of, multiplying so we add exponents, 13 plus 9 is 22. I will pause this for a second and do 3.7 times 7 with a calculator, which is 25.9. So that would be 25.9 times 10 to the power of 22. Now, we would want this to have one digit in front of the decimal point for proper scientific notation, so that is going to be 2.59 times 10 to the power of, we move the decimal point one extra digit, so instead of 10 to the 22, it will be 10 to the power of 23. So, which is larger, the number of meters across the Milky Way or the number of cells in all humans? 10 to the power of 21, 10 to the power of 23. Which is larger? This is larger. So, which is larger, the distance across the Milky Way or cells in all humans? Cells in all humans takes the win. Okay, problem 2 says ecologists measure the body length and wingspan of 127 butterfly specimens caught in a single field. Draw a line that you think is a good fit for this data. I'm going to grab my ruler here. Oops. On this, I want to approximate this data as well as I can. So I'm thinking it's going to look something like that. So now I've got a line. Draw a line that you think is a good fit. I've done that. Now I need an equation. For an equation, it's going to look like y equals mx plus b. Our b, we can tell, looking at this, is going to be 2 or 3. I'll call it 3. Now our m, our slope, rise over run, find a couple of nice points on our graph. 0,3 is a nice point we've already used. And how about the point right here? Looks like about 60, 19. So slope formula, rise over run, y2 minus y1, 19 subtract 3, over x2 minus x1, 60 subtract 0, which is equal to 19 subtract 3 is 16 over 60. Simplify that fraction a little bit. Both of those are even. So 8 over 30. Both of those are even. So 4 over 15. Our slope will be 4 over 15. There's our equation of the line. Y equals 4/15 x plus 3. You could get a different line depending on just how well you draw your line, how well you interpret the points, but I got 4/15. Our next question here says, what does the slope of the line tell you about the wingspans and lengths of those butterflies? Well, what does that tell us? It tells us that the body length grows by about 4/15 as the wingspan grows by 1. It tells us the body length goes up by 4/15 of a millimeter as the wingspan goes up by 1 millimeter. Okay, our next question here. Diego was solving an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but he can't find it. Where is Diego's mistake? And what is the solution to the equation? So let's look through Diego's steps and see where he might have gone wrong. -4 times 7 is -28. -4 times -2x. Ooh, I think I found his mistake pretty quickly. A negative times a negative is a positive. Let's check and see if we can find any other mistakes on this step. 3 times x is 3x. 3 times 4 is 12. Everything on that step looks to have been done correctly. So that was his mistake. Now, it says what is the solution? So I'm going to rewrite the equation from where we left off correctly. -28 plus 8x equals 3x plus 12. What can we do first? Combine like terms. There are no like terms. Then we have to get all of the x's on one side of the equation. Which side is better to get the x's on? Well, there's more on the left than there are on the right. I would like a positive number whenever possible, so I'm going to get them off the right and put them on the left. How do we get rid of 3x on this side of the equation? We subtract it. Do it to one side, do it to the other. Now, we have -28. 8x subtract 3x is 5x. Equals, those cancel out, 12. Now we've got all our x's on one side of the equation. We've got to get all our numbers onto the other side of the equation. How do we get rid of a -28? We add 28. Do it to one side, do it to the other. Those will cancel. We are left with 5x equals 12 plus 28 is 40. 5x equals 40. How do we get the x by itself? Divide by 5. Divide by 5. X equals 8. Sorry about that. That kind of trailed off the bottom of your screen. X equals 8. Okay, our next problem here is the two triangles are similar. Find X. Now, similar triangles will all have angles that are congruent to each other. Which means if this is 46 degrees, this is 46 degrees. If this is 106, this is 106. If this is X degrees, then this is X degrees. So we just have to figure out what X is. So I'm going to label, if this is 46, this also has to be 46 right here. 46 degrees. So now we know the angle sum of a triangle is 180. So we know that 106 plus 46 plus X has to equal 180 degrees. 106 plus 46, combine like terms, is 152 plus X equals 180. Subtract 152 from each side. X equals 28. So X over here is 28 degrees. Okay, that's our last problem today. This has been another Mr. Boskin Helps You With Your Math. Thank you for